To understand how these choices for material selection are made, look at things historically from about 10,000 BC, so about 12 millennia ago. And so you had just a very few number of materials. Natural materials over here, wood, for instance, animal skins, gold, then maybe some kind of stone, and some. Eventually, a few more metals came along, and so these were defined by copper age and bronze age and iron age, for instance. And pottery came along, glass came along, paper came along, different kinds of glues, and soon we get into steels, before that cast iron. Then polymers came along, recognizing from glues to uh, rubbers, and then bakelite was a big uh, progress, and then you ended up having a number of these synthetic plastics, and over time that has increased compared to being nowhere around. Um, Different kinds of cements came along over the period of time, starting from about 1000 BC. Eventually, in the metals also, there were a lot of innovations, and the light alloys, super alloys, titanium, all these kinds of things came along and continue to move along. And along with that, different kinds of manufacturing techniques that could translate those materials into useful shapes. Composites became a big thing and continue to grow, and as are some specialty ceramics and glasses that make a lot of things possible. So, compared to the few that were there, even at the turn of the previous century, now you have more than 160,000 types of engineering materials. So, from a design perspective, then the issue becomes, from all these options, which one do I choose for a certain application that will work best? And then, how do I, depending upon the shape, decide which manufacturing method can convert that material into a particular shape? So, this interrelationship between what a product should do, what it might look like, what it might be made of, and how do you make that into that shape with this material to deliver that function. So, the manufacturing process. These are the interrelationships. And in order to be able to navigate that space, you have design requirements that set constraints that limit what options are screened out, and then there are objectives that decide, based on the down selected options, how do you optimize between conflicting requirements. For instance, something should be strong but it should be light, something should be strong and light but it should be cheap, something should be able to withstand a certain level of temperature. So these are the design criteria in terms of constraints and objectives that we look at conducting our selection. Take one other type of application, in this case, a riot shield. Variation of this can be the face shields that are in place for PPEs during the COVID-19 crisis. So, what are some things that are required? Okay, face shield might have a very different set of requirement for PPEs compared to visors, even though the shield component itself has to be transparent. But in case of a law enforcement personnel as opposed to medical personnel, the fracture toughness should be very high. And of course, because you want it in large volumes, you want it to be molded. Okay, those could be some kinds of constraints. So what materials would be compatible for something like this? One type of question. Another type of question, going to a completely different sphere of application, is the area of power electronics. These come in very handy, for instance, in electric vehicles. For you have a high current density, so a lot of heat generated. And so how do you conduct out that heat in the package? So you need some heat sink, you need some cooling fan. Right? How much heat is generated? You don't want it to exceed 200 degrees C, but things that are thermally conducting tend to also be electrical conducting. And that won't do because there's an electrical application. So you should be able to have the combination of electrical insulation as well as thermal conduction. What kind of materials give those conflicting constraints and then also give service life thrown in, okay, in addition to everything else, right? So here are some constraints that are given.